In this video, we'll talk about how to obtain the Fourier series of a periodic function. If f of x is defined in the interval negative pi less than or equal to x less than or equal to pi, we can express f of x in terms of a convergent trigonometric series of the form f of x is equal to a naught over 2 plus summation n equal to 1 to infinity of a sub n cos nx plus b sub n sin nx. This is the Fourier series of f of x. A naught, a sub n, and b sub n are called the Fourier coefficient. So in a range negative pi less than or equal to x less than or equal to pi, we have that a naught is equal to 1 over pi times the integral from negative pi to pi of f of x dx. Okay, a sub n is 1 over pi times the integral from negative pi to pi of f of x cos ns ds. B sub n is 1 over pi times the integral from negative pi to pi of f of x sine nx dx. So a naught, a sub n, and b sub n are the Fourier coefficient. Let us obtain the Fourier series of the function f of x defined by this: 0 in this interval, negative pi less than x, and x is less than negative pi over 2. 4 in the interval, negative pi over 2 less than x less than pi over 2. And 0 in the interval, pi over 2 less than x less than pi. What we have to do first of all is to determine the Fourier coefficient a naught, a sub n, and b sub n. Remember that a naught is 1 over pi times the integral from negative pi to pi of f of x dx. Okay, so for this periodic function, what will be a naught? A naught is equal to this: 1 over pi times the integral. We'll take the first one from negative pi to negative pi over 2. Negative pi to negative pi over 2 of f of x, which is 0, ds. Then plus 1 over pi times the integral from negative pi over 2 to pi over 2. Negative pi over 2 to pi over 2. What is f of x? 4. That is 4 dx. Plus, we'll take the last one. 1 over pi times the integral from, we have pi over 2 to pi. Pi over 2 to pi. F of x is 0. 0 ds. This will turn to 0 and this will turn to 0 because the integral of 0 is 0. Okay, that's what we have. So we have just a naught is equal to 1 over pi times the integral from negative pi over 2 to positive pi over 2 of 4 dx. 1 over pi. The integral of 4 dx is actually 4x from negative pi over 2 to where pi over 2. Okay, so let's substitute the upper and the lower limit. A naught is 1 over pi. In place of x, we'll put pi over 2 first. So we'll have 4 pi over 2. Then minus, we'll now put minus pi over 2 for x. That will be 4 times minus pi over 2. So we have 1 over pi. 4 pi over 2 is 2 pi. All right? 2 pi. Minus minus is a plus. 4 divided by 2 is 2. So we still have 2 pi here. 2 pi. 2 pi plus 2 pi is 4 pi. So A naught is actually 4 pi. This is 4 pi. 4 pi times 1 is 4 pi divided by pi, that is under. So A naught is equal to what? 4. Pi will take away pi. So this is A naught. So for this periodic function, A naught is equal to what? 4. Having gotten A naught, let us now get A sub n and B sub n. Let's go with A sub n first. Remember that generally A sub n is 1 over pi times the integral from negative pi to positive pi of f of x cos nx dx. So for this periodic function, what is A sub n? A sub n is equal to 1 over pi times the integral from negative pi to negative pi over 2, negative pi to negative pi over 2. F of x is 0, 0 cos nx, that's 0 times cos nx dx, which actually give us 0, plus 1 over pi times the integral from negative pi over 2 to pi over 2, negative pi over 2 to pi over 2. What is f of x? 4. That's 4 cos nx dx, plus the last one, 1 over pi, the integral from pi over 2 to pi over 2 to pi. F of x is 0, 0 times cos nx dx. So let's evaluate this. This is 0 and this is 0 as well. 0 times cos nx is 0 and the integral of 0 is 0. The same thing here. So A sub n is now equal to what? 1 over pi times the integral from negative pi over 2 to pi over 2 of 4 cos nx dx. The 4 can come out because it's a constant. We now have 4 over pi times the integral of cos nx dx from negative pi over 2 to pi over 2. A sub n is equal to this 4 over pi. The integral of cos x is sine x. That is, if you integrate the cosine function, you obtain the sine function. So the integral of cos nx dx is sine nx all over n, negative pi over 2 to pi over 2. This n can come out and we'll have 4 over n pi times sine nx from negative pi over 2 to pi over 2. A sub n is equal to this 4 over n pi, all right, sine pi over 2 we enter for x, we have sine n pi over 2 minus pi over 2 we enter for x, we have sine minus pi over 2 times n is minus n pi over 2. All right, so we'll be having 4 over n pi in brackets sine minus x. For example, that's sine minus x is equal to minus sine x. That is, the minus will come out. So in this case now, the minus will come out, and if it affects this minus, it become a plus. So we're having sine n pi over 2 plus sine n pi over 2, which is actually 2 sine n pi over 2. Okay? So A sub n is equal to what? 4 times 2 is 8. That's 8 all over n pi times sine n pi all over 2. This is what A sub n is. So having gotten A sub n, what we have to do now is to determine the behavior of a sub n at different values of n. We are particularly interested in this sine function, okay? So when n is equal to 1, what is a sub n? When n equal to 2, what is a sub n? When n equal to 3, what is a sub n? And so on and so forth. Let's see. When n equal to 1, a sub n is simply 8 over n pi. That's n is 1 now. That's pi, 1 times pi. Sine 1 times pi is 180. 1 times pi is pi, which is 180, divided by 2, 90. Sine 90 degrees is 1. So we have 8 over pi. When n equal to 2 now, what is a sub n? A sub n is 8 all over 2 pi times sine. This is 2 times 180, which is 360, divided by 2. We'll still have 180. So sine 180. Sine 180 degrees is 0. So everything here becomes 0. So when n is equal to 3, when n equal to 3, what is a sub n? It's interesting. A sub n is simply 8 over 3 pi, because we have n pi, 3 pi, times sine. We have 3 times 180 divided by 2. That's 270. So sine 270 degrees. Sine 270 degrees is minus 1. So 8 over 3 pi times minus 1 is what? Minus 8 all over 3 pi. You can see that we are having different values of a sub n for n equal to 1, 2, and 3. Let's proceed a little further and see what happens. What is a sub n when n is equal to 4? Actually, it will give us 0. Look at it. A sub n is equal to this. We'll have 8 over 4 pi, 8 over 4 pi, times sine. So if we put 4 here, 4 times 180 divided by 2 is 360. So when n is equal to 4, we are having sine 360 degrees here. Sine 360 degrees is 0. This will give us 0. So just take note. When n is equal to 2, 4, 6, 8, 10, a sub n will be 0. That's what we have here. So we may not need to get the values of a sub n when n equal to 6, 8, and all other even numbers. When n is equal to 5, a sub n is equal to 8 over 5 pi times sine. 5 times 180 divided by 2 is 450. So sine 450 degrees is actually 1, to give you 1. Okay? So when n is equal to 5, we have sine 450 degrees, which is equal to 1. So 1 times 8 over 5 pi is actually 8 over 5 pi. We can see that the difference between a sub n when n is equal to 5 and the difference between a sub n when n is equal to 1 is just the value of n. Here n is 1 and here n is 5. So take note of this. Just like we said earlier, when n is equal to 2, 4, 6, 8, 10, 12, that's even numbers, a sub n is always 0. So when n is equal to 1, 5, 9, and so on and so forth, a sub n will always be positive. All right? We'll have a sub n as 8 over n pi. Let us determine a sub n for one more value of n when n is equal to 7. We don't have to look for a sub n when n is equal to 6 because it's still going to give us 0. So we will see that A sub n for n equal to 7 will behave the same way as A sub n for n equal to 3. It will give us the same negative value. The only difference is that the n will be 3 for n equal to 3 and the n will be 7 for n equal to 7. A sub n will now be 8 over 7 pi times sine. Let's put 7 for n. We'll have 7 times 180 divided by 2, and that is 630. Sine 630 degrees is minus 1. So minus 1 times 8 over 7 pi is minus 8 over 7 pi. So you can see that when n is equal to 7 and when n is equal to 3, the behavior is the same. They have both negative, negative, except for the fact that the n values are different. Here 3 and here it is 7. So for values of n, including 3, 7, 11, and so on and so forth, A sub n is simply minus 8 all over n pi. This must be noted. So for values of n equal to 2, 4, 6, 8, and so on and so forth, A sub n is equal to what? 0. So let's proceed now to determine B sub n. Now, let us determine B sub n of this periodic function. Generally, like we said earlier, B sub n is 1 over pi times the integral from negative pi to pi of f of x sine nx dx. So for this periodic function, this is what B sub n is. B sub n will be equal to, we may not need to take these functions that has 0, 0, 0, okay, because it will still give us 0. When we were determining a naught and a sub n, it was 0. So let's neglect it. Let's just take this one. So we have 1 over pi times the integral from negative pi over 2 to pi over 2. Negative pi over 2 to positive pi over 2. F of x is 4. That will be 4 sine nx dx. All right. So let's go ahead. B sub n will be equal to, 4 is a constant. If it comes out, we'll have 4 over pi times the integral from negative pi over 2 to positive pi over 2 of sine nx dx. The integral of sine x dx is minus cos s. So the integral of sine nx dx is minus cos nx all over n. So we're having 4 over pi times minus cos nx all over n. That n can come out to multiply this pi. So the integration is from negative pi over 2 to pi over 2. This minus can also come out. If it comes out, here become plus and here become minus. Okay, so let's proceed now. B sub n is equal to, we have minus 4 over n pi times, we'll plug pi over 2 first for x. That will be cos n pi over 2, then minus, we'll now plug in minus pi over 2 for x, cos minus n pi over 2. Yes, n times minus pi over 2 is minus n pi over 2. This is equal to 0. How? Cos minus n pi over 2 is cos n pi over 2. Trigonometry says that cos minus x is equal to cos s. So based on this, the minus will disappear from here. We now have cos n pi over 2 minus cos n pi over 2. And that will give us 0. 0 times what we have here is 0. So B sub n is actually equal to 0. Now that we have gotten the Fourier coefficient, A naught, B sub n, and a sub n. What now is the Fourier series expansion of that periodic function? Remember we said f of x is a naught over 2 plus the summation from n equal to 1 to infinity of a sub n cos nx plus b sub n sin nx. So as far as this periodic function is concerned, b sub n is always 0 for all n. So we may exclude this particular term. We'll just be dealing with a naught over 2 plus the summation from n equal to 1 to infinity of a sub n cos nx. All right? Just for this periodic function. So a naught is 4. We got a naught equal to 4. So 4 divided by 2, 4 divided by 2 is 2. F of x is equal to 2 plus, let us take the summation of this for different values of n. When n is equal to 1, what is a sub n? This is it, 8 over n pi. So when n is equal to 1, we can put 1 here. We'll have 8 over 1 times pi, which is pi. So a sub n is 8 over pi, then times cos x, because 1 times x is x, plus when n is equal to 2, a sub n is 0. 0 for 2, 4, 6, 8. So we exclude those numbers. We'll go to 3. When n is equal to 3, this is a sub n. So for n equal to 3, we'll have minus 8 over 3 pi. That will be minus 8 over 3 pi, then cos 3x. Let's continue the summation. Plus, when n is equal to 4, that's 0 for h sub n. So when n equal to 5, we'll have what? We'll have this. 8 over 5 pi. 8 over 5 pi cos n is 5. 5x. So the next one will be 7. We are supposed to take 6, but a sub n for n equal to 6 is 0. So for n equal to 7, it is still minus 8 over n pi, but it will now be minus 8 over 7 pi. So we have minus 8 over 7 pi cos 7x. So for n equal to 9, we're having 8 over 9 pi cos 9x. 8 over 9 pi cos 9x. And so on and so forth. F of x is now equal to, we have 2 plus, this is 8 over pi cos x, 8 over pi cos x, minus 8 over 3 pi cos 3x, minus 8 over 3 pi cos 3x, plus 8 over 5 pi cos 5x, minus 8 over 7 pi cos 7x, and so on and so forth. I want to neglect the other one because of space. So we can see that 8 over pi is common to all the terms. Okay, we can bring 8 over pi out, so that f of x will now be equal to 2 plus 8 over pi. Then all other things remain the same. We're having cos x minus 1 over 3 cos 3x plus 1 over 5 cos 5x minus 1 over 7 cos 7x, and so on and so forth. This is the Fourier series. All right, I hope you enjoyed the video. Keep supporting by subscribing to this channel, like and share the video to your friends and to your course mates. We are still on Fourier series. I'll see you in the next video.